Okay everyone, this is going to be the video for the day that I'm missing, September the 9th, 2019, and I am going to say that it probably won't be a full 50 minutes. I know that breaks your heart, but I think I'm going to have you kind of play with some stuff on your own, and if we did that in class, it would take up some of the class time. So I feel like that will average out, and you'll still get your money's worth for today's class. That I'm missing, I'm sorry. Okay, so I think that what we've done so far, I'm hoping that on Friday we will get through all of the fraction decomposition for the Egyptians. So I believe we've already done, I'm doing this in advance of Friday, so hopefully by now we've done the 4 methods for decomposing into unit fractions. A fraction into unit fractions. And you've already had some chances to play with it a little bit. I'm going to give some homework today, I think. If I don't give it on Friday, then I'll for sure have it on here for Monday. So I think you've already done all of these 4 methods. You can use the 2/n table that came from the Babylonians. And I'm sorry, that came from the Egyptians. And you can see that, I think it's on page 40 in your book. Or you can use our little formula that we have, that we came up with for 2/3k, anything that looks like that. Okay. Or you can use the splitting identity that we will do on Friday, so hopefully you've seen it by now. Or you can use Fibonacci. So some of the homework in the book actually asks you, oops, Fibonacci has 2 C's. It has it'll say, okay, you use the Fibonacci method to do this problem. You use the splitting identity to do this problem. So some of it says do it in multiple ways. Some of it says just use this one. So whatever the book says in the homework, that's how I want you to do it. Okay, so just a few notes about stuff that I see in the book and just in general in life. One of the things, I think, one of the reasons we are studying this, because a lot of times people will say, why are we bothering with how Egyptians worked with unit fractions? Because they can be so stinking tedious. So why are we doing this? And I think that it's just really important. I think the book is pointing out that fractions are important. So what I'd like for you to do is just kind of think about your daily life and think, is there anything that I do with fractions in it? Like, when do I use them? So fractions are all over the place. And if you don't believe me, then go buy something at Subway and see how, if everything comes out in nice, pretty, normal, even numbers, round numbers, then you're golden. But I think you're going to find that you have to pay pennies or quarters or whatever, and those are actually fractions of dollars. So you're going to see those there. I think you can talk about, oh, I split my sandwich in half or whatever. So fractions are everywhere. If you're going to be a teacher, I know I kind of say this every once in a while. Sorry if you're not a teacher, going to be. But if you're going to be a teacher, then you're going to work with students with fractions, and hopefully you have a really positive attitude about them and you understand some connections that are in there. You also see connections. If you're not going to be a teacher, that's okay. There are connections to basic math, basic algebra, and just the understanding of how advanced math works. So I know a lot of you are in some very advanced math classes, but here's a thought. If you were trying to take a derivative, let me finish that thought. Okay, so connections between basic algebra, basic mathematics, and the understanding of advanced math. So if you're trying to take a derivative and your original formula is something like, or your original equation is something like the cubed root of x squared plus 5, y equals the cubed root of x squared plus 5, and you want to take that derivative, well, what do you need to know? Hopefully, in my brain, I hear you saying, you need to know that this can be rewritten as a fraction in an exponent, right? So y equals x squared plus 5 to the 1/3 power. For instance, when I have taught calculus in the past, this exponent fraction rule type thing really sometimes bugs students, and it can be, if you're in a Cal 1 or a Cal 2 class, these fractions, just little bitty rules about fractions, can really kind of mess up your game, so to speak. So I want you to know that. Also, in as easy of a class as the level, I don't think it's easy necessarily for some people, but for you guys it would probably be easy. We have a class here on campus that's called Intermediate Algebra. And this is a developmental class. It comes before college algebra even. But they have to work with stuff. They have to do things like 3 over x plus 5 minus 1 over x minus 2 is equal to whatever, it doesn't matter, x over x plus 3. Okay, so they have all these lovely rational functions or rational equations or rational expressions, all kinds of things that rational is just a fancy way of saying fraction, right? So they have to deal with that, and they have to learn how to do that. So this is one of the most basic math classes that we have here on the campus, but they're having to do fractions. So it's all over the place in our math curriculum for sure. It's all over the place in your real life if you really, really think about it. So fractions are just out there, so be aware of that. Okay, a couple of little points, small points about Egyptians. Sorry about Egyptians. First of all, I cannot spell Egyptians. Sorry about that. The first thing about them is their fractions are very difficult to deal with, right? I know you've noticed this week it's slow and it's tedious. This past week, if you're watching this on Monday, slow and tedious to deal with. Especially, it's very difficult for us to look at it from 2019 when we have really lovely ways of dealing with fractions that can be fast and easy and all that, and you go, oh my goodness, what were they doing? So I think it's important to realize the advances we've had in math. I think that's one of the things I want you to get out of this class, is that, so when I teach calculus, people say, oh, that's, so easy, that product rule, that quotient rule, it makes sense, whatever, those kinds of things. And I think sometimes we'll teach to our students the product rule or the quotient rule, and we do it in like one day. One 50-minute of class, you get, I don't know, however many rules we can cram into one 50-minute of class. And people go, oh, well, I'm struggling with this and I don't know why. Well, the reason why is because we're showing you the shortcut method, right? We're showing you the fast and easy thing. This took years and years for people to develop. There used to be mathematicians who, what they did was work for kings or royalty or emperors or whatever. They were paid to do math. That's all they did all the time. So they spent literally their lives, their professional scholarly lives, working out math because, of course, if you're a king or an emperor and you're showing off, it pays to have the really good scholars, right? You can say, my mathematician is smarter than your mathematician. In fact, we'll talk about that a little bit later whenever we get into some of the other civilizations. So it's actually, I think, really important to know, yeah, their stuff is slow compared to ours, slow and tedious compared to ours. Sorry, I didn't finish that sentence, that point. It really is, but, we've got years and years and years of practice under our belt, so to speak, and lots of really smart mathematicians did a lot of work to make it easy for us. So I think sometimes whenever we try to cram that stuff down somebody's throat and say, here, go learn the product rule after 50 minutes working with me, you should know it, and then you as students are stressed out a little bit about that, I think it's okay for you to take a step back and say, it's okay for me to struggle with this because it wasn't invented overnight. It really wasn't. It took a long time to get to these things. So that's one thing. It's one of the reasons why they insisted on using unit fractions. And I know you know that because we've been dealing with it for the last week. But that really slows down what they're doing. The unit fraction bit is really a pain, right? One of the reasons they did that is because of their notation. So what you're going to see as we get on up into a couple of different areas, for instance, when we get to calculus, we will talk about the different notations that we use for finding a derivative, and we'll talk about, oh, that one's a very intuitive notation, and this one is not. So for us, I think whenever, like we mentioned in class, I think 6 with a bar over it for a fraction as an Egyptian, and we look at that and we go, well, how ding-dong are they? Because they could have easily said 1/6, and then they could have said 2/6 and 3/6 and 4/6 and just dealt with it. But there's something about, for the Egyptians, they really, really looked at fractions and said, there's only one thing that can be 1/6 of that object. So go back to the loaves of bread that we were talking about in class the other day. If you want to take a fifth of a loaf of a bread or a tenth of a loaf of a bread, to the Egyptians, there's only one thing that's a fifth. You pull out the fifth and the rest is 4/5, right? So they really felt like there's just this one thing, and it doesn't make sense to them to deal with 2/6, 3/6, 4/6, all that kind of stuff. So I think that's what you're seeing whenever you do that. It's not that they were just, not smart. It's just that they really had that concept. Okay. You'll also notice, hopefully you picked this up from what we've talked about, they didn't use any fractions that weren't between 0 and 1. Okay. So no fractions that are not between 0 and 1. So what does that mean for us? Well, we don't have improper fractions. We don't have things that are bigger than 1. We don't have negatives. We don't have all that stuff. So that's really going to be a huge limitation for us. All right. I think that one more little point about this for working with fractions is that you need to be able to practice with your fractions. If you're going to be a teacher, you need to be very confident in them. You need to be working with your fractions. If you are a teacher in the future, you don't want to scare students off with them, right? You want to work with them, maybe hold their hands a little bit to be able to do fraction stuff. So I think that's a point that you need to think about it. I think it's a downfall if you just teach algorithms to students. Yes, they need to know, okay, to get to add 2 fractions, I use a common denominator and that kind of thing. But that's why in the middle school areas we do some stuff with manipulatives and things like that, drawing pictures, so that they'll be able to compare that common denominator and have a concrete thing for it. So I think you'll see some of that. I hope that learning some of this stuff in the math history class will give you a little bit of insight into how your students are going to feel. Okay, so if you struggle, and again, I know not everybody in here is going to be a teacher, but a lot of you were. Probably about half the class was future teachers. Okay, so if you struggle working with, Babylonian stuff or Egyptian stuff or whatever, I want you to think about a student that's going to see that for the first time. What about a student who sees 2/3 plus 5/7 for the first time? And you want them to just, you just take this and you just get a common denominator and then you do this. Okay, that's true, but again, think about how the struggle is real for you if you're working with Egyptians and Babylonians and stuff like that. And think about your students. This is the first time they've ever seen any of this, so maybe it gives you a little bit of compassion. And even if you're not going to be a teacher, I think that, just looking at students that maybe you're sitting in the math lab working and you're working on some math history stuff and there are other students in there who are working on intermediate algebra and you're like, oh, that stuff's so easy. Well, not necessarily. It's easy for you, but think about where those people are coming from. So just some little pointers, little thoughts. All right, so what we're going to do now is we're going to talk about, in your book, there's a section on false position. So I'm just going to talk to you a little bit about that. That's going to be the bulk of the news. That other was just Dr. Webster on her soapbox. Sorry, it's kind of a long soapbox. But it's important, and I think that as we go through and you take tests and I'll say stuff like, why bother studying this stuff? Why look at fractions like Egyptians? I hope that some of those, even if you don't agree with all of my points, if you come up with some points of your own other than they made me do it, that would be good because you're probably going to have some why questions on a test. Okay. So what we see whenever we look at the Rhind Papyrus, one more thing, so we're still not done with that lovely document yet, is this false position thing. So what we know is Egyptians didn't do a lot of algebra. Okay. Not a lot. But just because they didn't do a lot of it doesn't mean that they didn't do any, and it doesn't mean that they didn't kind of set a precursor for algebraic thinking. So they did a little bit, and that's what we're going to look at. Okay. And then the last section in the book about Egyptians is on geometry. We'll see how far, well, the last section I'm going to cover with you. And we'll see how far we get on that and see whether or not we want to do it. Okay, so what did they do? They did a lot of real-world problems. A lot of the times that ended up looking, problems, I can't write again. A lot of times that ended up looking like proportions. Okay, and we'll see a lot of proportions when we get into Greeks. So proportional reasoning, proportional thinking, all of that. And sometimes it was geometry, but with a blend of algebra. So unfortunately, again, they didn't have the notation to call an unknown quantity X or Y. Okay, they just weren't to that level yet. But they did understand that sometimes you need to find an unknown quantity and do some stuff. So here's the idea that they have, and I'm just going to steal one of the problems out of the book and explain to you what this false position idea is. Because there's a whole entire section in your book. I think, yeah, it starts around page 46. Okay, here's what false position means for us. We're going to work on a problem. It's going to be an algebraic problem. And we're going to say, okay, the idea of false position is this. Just guess. Okay? You have a problem. You just guess the answer. Okay? Try to do a smart guess, an educated guess. Okay, and we'll see how that looks in a second when we're dealing with some fraction stuff. Yes, fractions are still hanging around, sorry. But we're going to make a guess. It's going to be an educated guess, but it's still just going to be a guess, okay? And then whenever we do that, we make our lovely guess, we're going to say, oops, wrong answer. Okay, so this is where the false position bit comes in, is because I'm taking a position, I'm taking a stand. Here's my answer. That's my position. Oh, it's wrong. Okay, that's all right that it's wrong. It doesn't matter. I just need to adjust based on my wrong answer. My wrong answer. That's okay. I'll use that, and actually what you'll see is if you look at the book, if you really read this section and look through it, there's we'll see later some stuff that comes from the Arab nations, and we already talked about we get our numbers from the Arab nations, and there's some stuff that comes down where they use this exact same concept, and it's basically like, oops, my bad, okay, I don't care, I'm just going to use my wrong answer and go forward, and I'll get the right answer, the correct answer, based off of my mistakes. That's okay. Mistake, a wrong guess. Okay. Doesn't matter at all. All right. So some of the problems that you'll see in your book about the rhyme papyrus, again, still on this document, is they go like this. So I'm just stealing this one from the book. It says, this is problem number 22 out of the rhyme papyrus, and it says, I want you to complete. So first we'll have to get to know what their complete means. I want you to complete 2/3 plus 1/30. Oh, 2/3, sorry, plus 1/30. I want you to complete that, okay? For them, what it meant is we want it to, we look at this and we say 2/3 plus 1/30. That's not quite a whole. Think about completing the square or completing the whole. I want that to add up to a unit, or we know that the unit value should be a value of 1, right? So basically what they're telling me is, okay, I've got 2/3 plus 1/3. We know it doesn't equal 1 yet. So I need to complete it. Think about completing the square. What does that mean? That means filling it in, right? So there's got to be some stuff. 2/3 plus 1/30 plus some stuff that I can add in there that will make it equal to 1. Okay? So the question is, what's that stuff? That's what it is. So if you look in your book, they actually come up with, and again, the guy who was writing the rhyme papyrus didn't have this notation, but they say, you know, come up with some number that I can multiply both sides of this equation from. Now think about this. Again, they didn't have equations. They didn't have the notation for an equation, x's and y's and whatever. But come up with some number that I can multiply by both numbers, or by both sides of this equation, and then I can equate it and figure stuff out. So it looks like this. N is some number. They just pick it. Okay, so pick some random n. Pick a random n, but make it smart. Okay, and again, think about these Egyptians doing this. That's what they want me to do. So pick some random n, make it smart. If I multiply both sides of the equations, it's interesting they knew they could do that, keep it balanced, by the same number. That's legal, right? That's okay. But if I do that, then I still have this idea of these things in here are going to equal to 1, right? Because I'm multiplying them by the same number. So if this side is n times 1, then this stuff also has to be a 1 whenever I get that n out of there. So think about it for a second. I've got thirds and I've got 30ths. What would be a smart number to use? I hope that in the background you're saying 30, because we know 30 is a really nice number because it's a common denominator, right? Okay, so if I multiply both sides of this equation by 30, again, it's just some random number, I just picked it, okay, but I tried to be smart about how I picked it. Okay, I can do that. I can multiply both sides by a 30, right? Okay, if I do that, why would I pick 30? Why am I picking something that's a nice, pretty common denominator? And the answer is because, well, look, 30 times 2/3, what's that? The 3's will reduce, it's 20, right? Because this becomes a 10. Let me do it like this. Okay, so that becomes a 10. Sorry about that. That becomes a 10 times 2 is 20, and it's reduced out. And what about here? That's a 1, right? Okay. And on the right-hand side, I've got 30. So we know that we didn't guess right. Okay, absolutely. I know I didn't guess right because this says 21, right? And I was shooting for something that would get me to 30. Okay, so I know I made a bad guess. I don't care. I knew it was going to be wrong. That's my false position. I picked a number. I went with it. It doesn't matter that it's wrong. I don't care. What I care about is now I have something that I can look at as a relationship. Okay, so what kind of relationship should I have here between these guys? I've got 21 plus something gives me 30. Well, what is it? It's a 9, right? I know I need to put a 9 in there, okay? But I can't do it as a whole number. I need to do it as fractions because remember, I just cleared out all my fractions. My actual question was 2/3 plus 1/30 plus some stuff equals 1. So I need this to be a fraction less than 1, or maybe multiple fractions that are less than 1, right? Put that. But I need them to be fractions. That's what I'm after. So, I need to add a 9. I know that for this whole number piece. But that's not going to get me where I need to do. So what should I do about that? So I want you to think about it for just a second. So the difference is that I know that I have 21. I know that I need something that'll get me up to 9. What can I do with that? How can I get to the 9? So what I really need here is some portion, something that I can multiply this by that'll give me a 9. What would it be? Think about it, think about it, think about it. If I multiply by 9 over 21, what would happen there? Oh, I'm sorry, hang on. I want to make sure I don't lie to you. I totally just lost my notes, I'm sorry.